So in this video, we are going to discuss about moles and molar mass. So this is going to be lecture number 1 for advanced placement chemistry. So first of all, let's see what we mean by moles. So we are familiar with the quantity of substance that we use different units to represent the quantity of substance. Like for example, dozen. We use dozen in our daily life to represent 12 quantity. Either that could be anything. Either that could be eggs and either that could be bananas. So you can see that because of our convenience, we are using different quantities to represent we use different units to represent the quantities. So in the similar way, you know like atoms, ions, or molecules, they are quite small, so it is impossible to count them. Okay, because they are quite small, so it is impossible to count them. So, because of the convenience, scientists suggest a unit which is named as mole to represent the quantity of a substance. So, mole is basically the SI unit of the amount of substance. Then, like 1 mole of any substance, this is very important, that 1 mole of any substance is equal to 6.02 times 10 raised to power 23. And the substance could be anything. Either that could be an atom, either that could be a molecule, or either that could be an ion. So you can see, like for example, there is basically a formula. The formula is going to be like number of particles, and particles could be anything. Either that could be atom, molecule, or ion. The formula is going to be mole times Avogadro's number, which is 6.02 times 10 raised to power 23. Like for example, if we say, like we have iron atom, okay, now you can see this is an iron atom. So 1 mole of iron, that contains 6.02 times 10 raised to power 23 iron atoms. Because it contains 1 mole, so it is going to be 6.02 times 10 raised to power 23 iron atoms. But if you see water, water is basically a molecule. So if water is a molecule, then 1 mole of water that contains, you can see mole times 6.02 times 10 raised to power 23. So if there is 1 mole of water molecule, so I'm going to put 1 here, 6.02 times 10 raised to power 23, and that would become 6.02 times 10 raised to power 23 molecule of water. That is going to be molecule of water. But if we want to count atoms in it, count atoms in it, you are going to see one thing, that 1 mole of H2O molecule is basically, H2O molecule that contains 2 hydrogen atoms, and it also contains 1 oxygen atom. So if we want to count the number of atoms, let's say first we count the hydrogen atoms. So they would be like 6.02 times 10 raised to power 23 multiply by 2. Okay, because there are 2 hydrogen atoms, so it would contains 1.2044 times 10 raised to power 24 hydrogen atoms. Like if you want to count oxygen atoms in it, so how many oxygen atoms will be? We know that it contains only 1 oxygen atom, so I'm just going to multiply it with 1 only. So that would become 6.02 times 10 raised to power 23 oxygen atoms. And if they want us to find out the total number of oxygen, total number of atoms, let's say, so total atoms in you can say H2 molecule, that is going to be, we are just going to add them, 1.2044 times 10 raised to power 24, that is for hydrogen atom. I'm going to add it with oxygen atom, that is 6.02 times 10 raised to power 23. So total number of atoms in H2 molecule, that would become, I'm just going to add them together, so it would become 1.8066 times 10 raised to power 24. These are total atoms that are present in water molecules. Like for example, now we have an ionic compound, and that is going to be aluminium sulfate. So this is aluminium sulfate, and it has the formula which is Al2SO4 whole thrice. Now, so we have 1 mole of aluminium sulfate, and as it is an ionic compound, so 1 mole of Al2SO4 whole thrice, that contains, we have a formula, mole times Avogadro's number. So before it was a molecule, so we have first found the number of molecules of water. But it is an ionic compound. So in order to represent an ionic compound, we are going to use, instead of molecules, we are going to say it is going to be formula units. So the formula units in this ionic compounds, they are 6.02 times 10 raised to power 23 formula units. And now if we want to count the atoms there, so counting atoms. So you must know that in Al2SO43, how many aluminium atoms are there? There are basically 2 aluminium atoms. So the number of atoms would become, so if we say the number of aluminium atom in Al2SO43, that is going to be 2 times this value of formula unit, that is going to be 6.02 times 10 raised to power 23, and that comes out to be 1.204 times 10 raised to power 23 aluminium atoms. Then we have sulfur atoms. So you can see how many sulfur atoms are present there. This 3 is multiplied with this sulfur. So there are 3 sulfur atoms. 3 sulfur atoms. So I'm just going to find out the number of sulfur atoms by multiplying this formula unit, which is going to be 6.02 times 10 raised to power 23, and I'm going to multiply it with 3. So the answer comes out to be 1.8066 times 10 raised to power 24 sulfur atoms. And if we say like it is going to be we need to find oxygen atom. So how many oxygen atom would be there? This is 4 and 4 is multiplied with 3. So total oxygen atom would become 12 oxygen atoms. So now if I want to find the number of oxygen atom, what I'm going to do, simply I'm going to multiply 6.02 times 10 raised to power 23 multiply by 12, and the answer comes out to be 7.2264 into 10 raised to power 24 oxygen atoms. Now we need to add all of the atoms, so total number of atoms becomes, that is going to be 1.2044 times 10 raised to power 23. I'm going to add with 1.8066 times 10 raised to power 24, that is for sulfur atom, before it was aluminium atom, and then I'm going to add for oxygen atoms. So it would become 64 times 10 raised to power 24. So now the answer, final answer would become, we just need to add them together. So it is going to be 1.023 into 10 raised to power 25. These are the total atoms which are present in aluminium sulfate, in Al2SO4 whole thrice. So you must need to know that how we can find the number of atoms. Now further, I just want to discuss the last thing with you is the counting the ions. How can we count the ions? Like you know that aluminium sulfate Al2SO4 whole thrice, that would contain 2 aluminium ions, because you can see this is 2 here and plus 3 charges on aluminium, and there are 3 sulfate, and sulfate has a -2 charge. So if I want to find out the aluminium ions, let's say, you know the formula unit was 6.02, formula unit of Al2SO4 whole thrice is 6.02 times 10 raised to power 23. If we want to find the aluminium ions, it is going to be 2 times 6.02 times 10 raised to power 23. So it is going to be 1.2044 times 10 raised to power 24. These are aluminium ions. If I want to find out sulfate ions, so that is going to be 3 times 6.02 times 10 raised to power 23, and that is going to be 1.8066 times 10 raised to power 24 sulfate ions. So total ions now become how much? 1.2044 times 10 raised to power 24, and I'm going to add sulfate ions now. 1.8066 times 10 raised to power 24. These are sulfate ions. So the total ions would become 3.011 times 10 raised to power 24. These are total ions. So in this way we can calculate the number of ions over there. Now let's move towards our next topic, that is going to be masses and particles. So if we are talking about masses and particles, so first we need to find out what is basically the molar mass. Molar mass is the mass of 1 mole of a substance. Okay, like molar mass we can find out from the periodic table, and the unit of molar mass is gram per mole. You know, the one carbon atom has the molar mass of 12.01, that is in gram per mole. And for zinc it is going to be 65.38 gram per mole. So we found this one from the periodic table. We can find these values from the periodic table. Now there is a formula which links molar mass and the moles. So the formula is going to be mole is equal to mass divided by molar mass. So if we are talking about this formula, you know, like for example, we have a question. Up till now I have told you about two formulas. The one is going to be number of particles, which is equal to mole times Avogadro's number. So now by using these two formulas we are going to solve certain questions. Like first of all we have a question: how many molecules of C6H14 does a 42.0 gram sample of C6H14 contains? So they want us to find the number of molecules, and for that purpose, you know, this first of all you must know about this thing, that this C6H14 is a molecule that is formed by covalent bonds, so it is a molecule. So we are going to use a formula that is going to be we know about number of particles. I have told you before, particles can be molecule, can be atom, or can be ion. So number of molecule would be mole times Avogadro's number, and for that purpose we must need to find the mole first. So mole is equal to mass is 42 divided by molar mass. So carbon is 12.01 times 6 plus how much is H? H is going to be 1.008. So there are 14 H. So I'm multiplying with 1.008. So the final answer of moles that comes out to be 0.4874 moles. I'm just going to put the values there. So that is going to be 0.4874 times Avogadro's number. So that comes out to be how much? That is 2.94 times 10 raised to power 23. So these are the number of molecules that we have found from here. Thank you so much for watching.